In section 8.1, we discussed the testing hypothesis for two population means. Today, we are going to discuss a testing hypothesis for two population variances. Let's consider some example. Maybe the first example is when you test two population means, we divided two cases such that whether we can assume two population variances are equal or different. Can you do some test statistically? That's the issue of this section. More practical example look like a quality control problem. Suppose you have two companies which produce bolt. Maybe if they might have the same quality of diameter, but if diameter variance is smaller than the other company, that means you make a good product. Why variances matter? If variance is small, you are producing accurate bolt, accurate product. If variance is large, there is more chance of defective. Therefore, testing variances is always used to check the quality of product. Well, we need a sample statistic to test two population variances are equal or not. Here's a sample statistic. I think you have not seen these things. Okay. Well, sigma 1 square, sigma 2 square will assume to be known. Then it is sample variance ratio. It follows F distribution. Okay. Well, F distribution has two parameters like n1 minus 1 and 2 minus 1. Okay. Depending on this parameter, the F distribution maybe has a little different. But in general, it is a skewed distribution. Let's look at the F distribution in your East and New module. If you click F distribution, it looks like this. Okay? Maybe default is 5, 10. They look like this. If you switch some other degree of freedom, this is numerator, this is denominator. Well, it looks like this. Well, in general, it is a skewed distribution. If you have a smaller number of degree of freedom, it is more skewed. On this F graph, you can check two-sided probability, the interval probability, or left tail, right tail as usual, and then some kind of percentile, two-sided or one-sided like this. Okay. Let's consider example to use this sample statistic. The test statistic, the previous one, we want to test that whether two population variances are equal or not. If they are equal, on this sample statistic, you can cancel out this one, sigma 1 square equals sigma 2 square, when H0 is true. Therefore, test statistic is nothing but the sample variance ratio. That's the reason we have this one. Depending on alternative hypothesis, you may have right criteria, right tail criteria, left tail criteria, or both tail. Okay? Since we have a skewed distribution, you need to specify each of them. In case of 5%, the significance level, left tail the 2.5%, right tail 2.5%. Let's consider the bolt example. You have two production lines. They show the variance like this, 0.11 square, 0.13 square, like that. You want to test whether two population variances are equal or not. Then you need to check left tail 5%, 2.5%, right tail 2.5%. Inside of that value will accept H0. Well, if it is outside, you will reject it. Sample variance ratio is 0.716, and this is left tail value of 11.9 because you have 12 data on plant 1 and 10 data in plant 2. Therefore, you have to look up this F distribution. It looks like this. Since 0.716 is inside of this interval, you cannot reject H0. Okay? H0 is accepted. That means two variances are equal. How can you practice using East and U module? Testing hypothesis, sigma 1 square, sigma 2 square. It is so simple. You choose appropriate alternative hypothesis, significance level, and plug in numbers, okay, N1, N2 sample variances. Then they're going to calculate variance ratio. That's the F value, F0 value. And your test statistic is located here. Suppose you have some real number, then East and module can proceed this kind of data. You can test whether two population variances are equal or not. I think if you click EX button, you can find the data we have. I think it's example, that's wage by gender data. Okay, we practice these things, and then we tested whether population means are equal. But it's time to check testing two population variance. This is it. Here you click analysis variable. The first click is like this. Second click is the group variable is gender. Then this is the initial graph to compare population mean. But at the same time, this is standard deviation, one standard deviation. You can compare that. Okay? It seems not much deviation. You can select one of these, select significance level, and click F-test. Will give you the F distribution, where is the test statistic, and they calculate p-value. You have a corresponding the output in the log area. Okay, as far as you understand the sample variance ratio is a criteria, then the rest of them you can use E-stat easily to get some answer. Okay, these are the practice we have done. That's for all today. Next lecture, we are going to discuss testing hypothesis about the two population proportion.